begin to read of chapter 13, section 3, river valleys. Formation of a river valley begins on a small scale. A single heavy rain may form a small valley and loose soil along a hill slope. When the rain ends, the stream may disappear, but the small valley remains. Such a feature is called a gully. Gullies grow in length, width, and depth every time it rains. The process by which land is worn away at the head of stream or gully is headward erosion. Headward erosion lengthens streams or gullies. As a valley grows in length and depth, the stream may eventually cut down far enough to become permanent. When the tributary gullies also become permanent, a river system is born. Most of the world's river systems probably began in this way. Canyons and V-shaped valleys. The streams of mountain regions and high plateaus are likely to have formed relatively recently. The amount of precipitation in a given area is one of the most important factors affecting the formation of the young or youthful river valleys, because more surface water means greater erosion. Some river valleys have very steep, almost vertical sides. Such valleys, which are often called canyons, gorges, or chasms, tend to form in regions with less rainfall. They can also form when a river cuts into its bed rapidly, or when the rock material on the sides of the valley are resistant to erosion. Factors that affect the length of time it takes a river to form a canyon include the type of rock the river must erode, the amount of water and sediment in the river, and the climate of the region. The Colorado River is thought to have taken millions of years to cut the mile-deep Grand Canyon into the rocks of the Colorado Plateau. Most youthful river valleys are V-shaped. Such valleys are found in regions where there is enough rain to erode the sides of the valley. As the river cuts its way down into its channel, the upper valley walls are widened into a V-shape by erosion. The Yellowstone River, shown in the photograph below, is an example of a river that has eroded its valley into a V-shape. That V-shape can be definitely seen here. V-shaped valley formation. In graphic number 1, you can see that a stream cuts down into its channel. In graphic 2, as the stream cuts down, the sides of the valley are eroded. And finally, in graphic 3, over time, a V-shaped valley is formed. A stream cannot erode its bed to a level any lower than the level of the largest body of water into which it flows. This level is called the base level of the stream. For streams that flow into an ocean, the base level is sea level. Sea level is also the ultimate base level because all rivers eventually empty there. Lakes and rivers are local base levels for the streams that run into them. An example would be the Fox River that flows into Green Bay at its base level. As the stream approaches its base level, the gradient of the stream bed and the velocity of the stream decreases. Thus, there's less erosion of the bed and more erosion on the sides of the channel. The resulting valley is wider with a broad floor and gently sloping walls. The headward erosion that brings about the formation of a river valley is an important factor in a process called stream piracy or stream capture. Picture two rivers separated by a divide. Through headward erosion, one of the rivers wears through the divide and captures the headwaters of the other river. The first river grows larger and extends its drainage basin at the expense of the captured river. Geologists think that stream piracy has been an important factor in the early growth of many great river systems. A stream running through a steep mountain region flows over ever-changing slopes. Riverbed may be steep enough to form whitewater rapids, may level out into a lake or a pond, or the stream may plunge over a cliff to form a waterfall. Many processes have led to the development of the steep slopes and cliffs of rapids and waterfalls. The Great Falls of the Potomac have formed where the Potomac River flows over hard igneous rocks onto soft sedimentary rocks. The two Great Falls on the Yellowstone River in Yellowstone National Park flow over hard igneous rock and down onto more easily weathered rock below. The falls in Yosemite Valley in California were formed when glaciers eroded one valley more deeply than others. This is a graphic of Niagara Falls. Goat Island divides Niagara Falls into the American Falls on the left and the Canadian Falls on the right. Canadian Falls are also called the Horseshoe Falls. All of these falls used to be a lot farther to the east than they are, but they're eroding back to the west. Because stream erosion is greatest at rapids and waterfalls, they're temporary features of streams. One way in which streams erode at waterfalls is by undermining. The water falling into the plunge pool at the base of the waterfall erodes the rocks there, leaving the rocks at the top of the falls to overhang. From time to time, pieces break off the top. Each time this breakage occurs, the waterfall recedes farther upstream. A famous example of a waterfall that recedes by undermining is Niagara Falls. Here the falls are the result of a nearly flat-lying 20-meter thick layer of tough dolostone. Dolostone is a rock similar to limestone, but it's made of dolomite rather than calcite. The rocks underneath the dolostone are almost all thin beds of shale. The rapidly eroding shale undermines the dolostone. Consequently, the base of American Falls is littered with huge blocks of fallen dolostone. The Niagara Gorge marks the path of recession of Niagara Falls. The gorge extends from the base of the falls to Lake Ontario, a distance of about 11 kilometers. At the end of the Ice Age 12,000 years ago, Niagara Falls was located on or near Lake Ontario. The recession of the falls since that time has carved the gorge. Horseshoe Falls, shown in the photograph above, erodes its ledge at a rate that can vary from 8 centimeters to 2 meters per year. The graphic on the right illustrates how the different layers of rocks in Niagara Falls and how the undermining occurs. At this time, you need to answer questions 1 through 4 on the back of your note-taking guide.